Welcome to The Explainer. Okay, today we are diving into something absolutely huge. We're looking at a monumental structural shift happening in technology right now. We are moving away from standard, static conversational AI, and we're officially entering the era of autonomous digital workers. It's a leap that is literally going to change how we interact with the digital world from the ground up, and I am so thrilled to unpack exactly how this all works with you today. Let's get into it.
Think about your daily interactions with AI for a second. Most of us are incredibly familiar with tools like ChatGPT or Siri or Alexa, right? We ask a question and they give us an answer. But have you noticed the big limitation there? While these tools are undeniably brilliant at talking, they don't actually do much for you. They're essentially passive. They just sit there waiting for your prompt, they give you a single pass answer, and then they stop.
Okay, let's dive into this comparison because this is where it gets good. What we've been using up until now is standard generative AI. You can think of it like System 1 thinking. It's fast, it's intuitive, but it's totally reactive and passive. It's built for answering. But what we are transitioning to right now is Agentic AI. These are System 2 thinkers. They're slower, they're methodical, they are active, and they are strictly goal-oriented. We're not talking about chatbots in a trench coat here. These are digital agents built for doing.
So here is our roadmap for this explainer. 1. The shift to agentic AI. 2. Defining the AI agent. 3. The PEAS framework explained. 4. The perceive, think, act loop. 5. 3 types of agents. And finally, number 6, real-world AI applications.
All right, let's kick things off with part 1, the shift to agentic AI.
And that brings us right into part 2, defining the AI agent.
Before we get bogged down in heavy engineering concepts, we really need to strip away the jargon and establish a solid, foundational definition. At its very core, an AI agent is an autonomous software system that can perceive its environment, make decisions, and take actions to achieve specific goals. Think of the difference between a specialist technician and an operations partner. Traditional AI? That's the technician. You say, hey, identify a cat in this photo, and it does precisely that one thing. An AI agent is your partner. You say, book me a vacation to Japan within my budget, and it actually figures out the steps, navigates the websites, and makes the purchases. A really great physical analogy for this is the robot vacuum. A regular vacuum only works when you physically push it, right? But a robot vacuum has agency. It perceives the walls, decides where to move next, and acts on those decisions to achieve its goal, which is a clean floor.
Which leads us perfectly into part 3, the PES framework explained.
So you might be wondering, how do engineers actually build that level of autonomy? Well, any intelligent agent is designed using what's known as the PAES framework. Let's map these abstract terms to our physical world using a self-driving car. First up, P is for performance measure. You can think of this as the agent's report card. For a car, success isn't just about moving forward. It's about arriving safely, obeying traffic laws, and keeping the passengers comfortable. Next, E is the environment. The actual physical roads, the weather, the pedestrians it has to navigate around. S stands for sensors. These are the eyes and ears receiving data, like cameras and radar. And finally, A stands for actuators. These are essentially the muscles used to act upon the world, like the steering wheel and the brakes.
Now, in a modern digital agent, the brain connecting those sensors to those actuators is a large language model, or LLM, and it acts as the central controller. This brilliantly illustrates how modern AI actually uses memory. See, this brain relies on short-term memory to keep track of the current task at hand, kind of like your own working memory. But it also uses long-term memory. It pulls from this massive vector database of past experiences and files to make informed decisions over time. Let's move on to part 4, the perceive, think, act loop.
Now that we have the static parts down, the sensors, the actuators, the brain, let's put this engine into dynamic motion. When an agent is working for you, it runs in a continuous loop. Perceive, think, act, and learn. Let's use a relatable scenario here. Imagine you open a travel app and type, "My flight was canceled due to a storm. Get me home tonight." Okay, step 1, perceive. The agent senses its environment by pulling your location, flight status, and weather reports. Step 2, think. Using chain of thought reasoning, it breaks that massive goal down into subtasks. It thinks logically, okay, I need to find a new flight, check the budget, and message the user. Step 3, act. It uses its actuators, which in this case are external APIs, to actually go and book the ticket. But here is the real magic. Step 4, learn. Let's say the booking website throws an error. The agent doesn't just crash and give up. It self-reflects, realizes that specific seat is taken, and then loops right back around to find the next best option.
All right, part 5, 3 types of agents.
Now, what's really interesting here is that this level of self-correction requires a highly sophisticated system. And that brings us to the fact that not all autonomous systems are created equal. There is a whole evolutionary hierarchy here that creates a sort of good, better, best mental model for us. Down at the bottom, we have simple reflex agents. These just react based on hard-coded if-then rules. Like, if a comment has a banned word, delete it. It doesn't really think, it just acts. In the middle, we have goal-based agents. You give them a target, and they proactively explore different paths and plan out multiple steps to reach that specific finish line. And at the very top, we have learning agents. These are the absolute pinnacle. They evaluate the success of their past actions and actively update their own strategies, meaning they don't repeat the same mistakes in the future.
And finally, part 6, real-world AI applications.
I know this all sounds amazing in theory, right? But let's step out of the theoretical lab for a minute and prove that this isn't just science fiction. Let's look at the realities of enterprise production today, because agents are already hard at work. For example, Klarna is using agents right now to autonomously resolve customer refunds, navigating different databases totally directly. In software engineering, an agent like Devin doesn't just auto-complete code. It actually reads a bug report, writes the fix, runs a test, reads the error logs if it fails, and then rewrites the code all on its own. PagerDuty Advance uses agents to monitor cloud infrastructure, isolate trace logs, and even restart broken servers without any human intervention. This is huge because agents replace rigid, dumb automation. Think about it. If a website button moves an inch, traditional automation breaks. But an AI agent, it just visually perceives that the button is in a new spot, adapts its reasoning, and clicks it. It thrives in messy, unstructured tasks.
But we do need to disrupt the hype for just a second with a pretty sobering reality check. According to the data, 88% of enterprise agent pilots never reach sustained production deployment. They fail.
So why do they fail so often? Well, it really comes down to the math of compounding errors and sequential workflows. Let's say you build a workflow with 3 agents chained together. If each individual agent is pretty good, let's say they each have a 70% success rate. Your overall end-to-end success rate drops to just 34%. And that is just unacceptable for a business. These failures usually happen due to something called context poisoning, where messy enterprise data basically confuses the agent's memory. Or they suffer from silent tool failures. This is where an API returns an error, but the agent completely hallucinates that it was successful. It confidently continues down the wrong path, all while the system monitoring tools report that everything looks totally fine.
So the crucial point here is that you absolutely cannot just unleash an LLM into your company's database and hope for the best. Production-grade agency requires strict engineering safeguards. You need hard sandbox separation, so an agent can never, ever accidentally delete your core databases. You need dual model verification, where a second, totally separate AI double-checks the logic of the first AI before any action is actually taken. Engineers also have to use Poka-Yoka. That's a mistake-proofing design that forces the agent to use strict drop-down menus instead of open text fields. And finally, you have to monitor the agent's behavior continuously, keeping a close eye out for anomalous loops or weird latency spikes.
The transition we've explored today really shows that the future of AI is not just generative. It is unequivocally agentic. We are moving from tools that merely talk to systems that actually do. And as these autonomous digital workers become more reliable and deeply integrated into our daily lives, a massive shift is going to happen to us. Our primary role is going to change from doing the manual work ourselves to managing, guiding, and setting the core values for the agents that do the work for us. So the question I want to leave you with is this. When you are no longer the one executing the day-to-day tasks, what new, high-level goals will you decide to pursue? Thank you so much for exploring the architecture of AI agents with me on this explainer. Keep learning, and I'll see you next time.